All right, we're going to be talking about surface area today, and there are some formulas. We're going to do two shapes today and then some more tomorrow. Today we'll look at prisms and cylinders. There is some vocabulary to go with each of those so that we can talk about the shapes and understand what each other is saying. So there are a number of terms to describe here. Let's start with the triangular prism. The bases are still the triangles, but good point there. Okay, so lateral face. There are right prisms and there are oblique prisms. As you look at the picture, can your mind interpret correctly? A right prism, these lateral faces are all rectangles. So the one I'm holding here is a right prism. These are all rectangles. If it's oblique, let's see, I don't have exactly the same shape, but this is an example of an or squished. I think of a slinky. If the slinky is straight up and down, that's a right, in this case, cylinder. But if it's squished off to the side, that's an oblique cylinder. So oblique basically means off-centered, off to the side. So it's not just a bad picture, but it means to be slanted off to the side there. There's an altitude that we'll use a lot in formulas. The altitude is the height of, like the prism or the cylinder or the pyramid. Heights, just like distances we talked about earlier, have to be measured at a right angle. Now, why is this out to the side here? Why doesn't it just go on the edge?
Because that's not the true height.
Okay, that is what kind of a prism then? Height of the prism, height of the triangle. They're not always the same measurement. So that gets a little confusing. We'll have to clarify what we're talking about as we do formulas. Okay, so altitude is a perpendicular height. Might be the edge, might be perpendicular, as in the picture, because of it being an oblique shape. All right, so surface area is what we're going to work on for the next couple of days. Surface area is the area of every surface. So if we had a nice cube, what are the surfaces? They're squares. There's 4, 5, 6 total squares. So if we found the area of all those squares added together, that would be the surface area. Yes. That was your lateral area. All right, as we're thinking through that, the two formulas that we're using are the top ones on your notes there. The lateral area of a right prism. Right prism meant that these are rectangles, not parallelograms. Okay, if the base perimeter is P and the height of the prism. So you might make a note that that height is the distance between the bases, how far from one base to the other. It doesn't always go straight up. Depends which way the object is laying. But the lateral area is the perimeter of the base only if it's a rectangular prism and it just does every face separately. So that's up to you if you want that one. And on the wall, the cube formulas are above me here, and the prisms are the first two on this poster. We'll eventually get through all of these. All right, so let's have you try a real calculation for an example. Okay, so you need a diagram. There's your rectangular prism. And let's actually try and calculate the lateral area, then the surface area. Right here, lateral area of a right prism. The one I'm doing, maybe just want to do it in the We're doing a rectangular prism to start with. Okay, so let's use the rectangle it sits on as the base face. That way we'll all be talking about the same perimeter and height. How do you get lateral area? What does the note say to do for prisms? Lateral area is perimeter times height. Perimeter of what? The base face. And I'm telling you this time, let's use the rectangle on the bottom. So the perimeter would be 9 plus 7 plus 9 plus 7, which is 32 times, what's the height? How far
14.
from that to the other one? 14. So 32 times 14 is 448. What kind of units would lateral area be?
Areas.
It's area, so
Q. Square.
squared. And we've got feet, so square feet on this one. Okay, lateral area, so that's going around it. Okay. Now for surface area, we need that plus
Oh.
the top area and the bottom area. So the area of the two bases. So surface area is gonna be that
9 times
448 plus
9
two
times-
base areas. What shape's the base?
Square.
Not quite.
Oh, rectangle.
With 9 and 7 for the sides. It's a rectangle. How do you get the area of it?
Base times height.
Okay, so 9 times 7, 63. So 63 times 2,
126.
we have to add that on to the 448 that we had. Times 74 square feet will be our total surface area. That's how much wrapping paper we would need in order to wrap that box.
That's a big box.
That's a big box. I don't know what would be that big.
No.
Hopefully we would lay it down the other way.
No,
That would keep
Maybe
you
a car
guessing
box.
if you got it in that one's that way. Big
A big
freezer,
freezer.
refrigerator.
Merry Christmas, son, you got a freezer.
That's a big freezer.
You want a freezer, Miguel?
I feel like one of those walk-in freezers. Parents will just shut you in there.
Whatever.
Leave it.
Okay, let's try another one. Base edges are all 10. 10, 10. And what's the height of 20 mean? Where's that at? Okay, it's in between the triangles. So from one triangle to the other, depending which way you drew it, from one triangle to the other is the 20. I noticed that. I shouldn't have used 10 up there. Okay, lateral area. Lateral area of the prism. Perimeter of the triangle in this case. The perimeter of the triangle is going to be, well, 30 is the perimeter of the triangle. Then you're going to multiply it by the height of 20. So 30 times 20 is 600 square centimeters for the lateral area. That's going around the triangle. Then for surface area, we have to add on two triangles, base and height of the triangle. It's the base edge. 10 is the height. Unfortunately, we did that up there, but 5 times the square root of 3 was the height. Okay. Now, if it had been 8, what would the height be? 4 square roots of 3. Right. All right, so triangle was 1/2 the base edge times the height that we figured out earlier. So we almost did this one on the board to start with. So 600 plus, let's see, 2 times 1/2 is just 1, times 10, times 5, times square root of 3, 50 square roots of 3. The parentheses would have been 25 square roots of 3 times 2. So what do we get for a final surface area? 686.6 square centimeters. Ask questions? Clark, did you get an example, Dan?
Yeah,
Calculated or just drew?
I got it drawn.
Well, we've done a lot of calculating here.
Yeah, I know how to do it.
All right, questions? Okay, let's do I think the next one's a cube, maybe. All right, cube. Find the lateral area. Okay, now there's two ways to do this. And there's two ways to do this one. And I use the actual, just looks like prism formula. I don't know why I did that. I was thinking I did the other way. If you did the lateral area of just the cube, 4 times side squared, that would still be 256. And if you did the surface area as 6 times the side squared, that would be 384 for that one also. But I treated it like a prism. It looks like some of you did the same. Question on one of those methods? Okay, if you're not asking, that means that you got it. Okay, cylinders. Cylinders are kind of like prisms, but the bases are circles. They're not rectangles or triangles. Actually, they're easier because all cylinders have a circle base. So, lateral surface is going to be the curved part that goes around it. If it's an oblique cylinder, it's going to be slanted. I kind of showed you the slinky and this green cylinder that someone made for me. It slants rather than being perpendicular. Okay? Those are hard to find surface area of because of the shape of this one going around it. If it's nice perpendicular, what is the shape of the thing going around it?
Circle.
What shape? Going around, it's going around a circle. If I would like slice this plastic and straighten it out, what shape would it be?
It would be a bigger
A
thing.
rectangle. How long does that rectangle need to be?
Long enough to wrap around the circle.
Which would be the circumference of the circle. Okay? So the lateral area, aren't we gonna have to take the circumference of the circle times the height of the cylinder?
Yeah.
That'll be our lateral area. Then what will we add on to that for the surface area total?
The circumference of the area of the circle.
The area of the circle and the area of this circle. So we'll have to add on 2 circles. As we look at the formula, that's what I've done here. Lateral area is 2 pi r, that's circumference, times the height of the cylinder. Surface area is that same lateral area plus 2 circle areas, 2 pi r squared. Now if you want to use lateral plus 2 base, you can and think about it, but this with the pi's is specific to the cylinder because I filled in the formulas for the circle. All right, let's try and do a cylinder. Find the lateral area and the surface area of this right cylinder, and we'll just leave the answer in terms of pi. So your answer might be that it's 200 pi square inches. I'm not going to hit the pi button and go to decimal. So lateral area calculated how? Lateral area for a cylinder. Not on that page. Cylinders. Lateral area, 2 times pi times the radius times the height. 2 times pi times the radius times the height. What's the radius?
8.
8. What's the height?
Okay.
Now, if I don't put in the pi, I'm just multiplying the other numbers. 2 times 8, 16 times 10. Okay, so this is 160 pi square inches for the lateral area in terms of pi. Surface area is that same thing plus 2 circles. And again, you said the radius is 8. What's 8 squared? 64 times 2, 128. So we have to add on 128 pi to the 160 pi that we had for lateral area. So that makes a total of 288 pi square inches. Okay, clarifying questions? Riley, got a question? No? Samantha? Okay, cylinders can be easier than the prisms. Okay, let's do one more cylinder before we look at a combined one. Now this one you have to, okay, you divide it by pi to get the diameter maybe to be 24. Radius was half of that. Okay, so the radius is 12. Shall I show how to do that? Did you do it? Did you get the radius? Okay, what's the height? Height is equal to half the radius. Height is 6. I think that's all we need to do the surface area and lateral area. Lateral area, 2 pi RH. So 2 times pi times 12 times 6.
144 pi.
Okay. Square centimeters. And surface area would be that plus 2 pi RH. Radius we said was 12, so we'll put a 12 in there. 12 squared is 144 times 2. That 288 pi. Yes.
Is it okay when you're putting in the circumference for like the lateral area that you just used was 24 pi?
Sure. So you took 24 pi times 6? Yep. That'll work. And what do we get here? 432 pi square centimeters. So as you work through, does it make sense that the cylinders actually are a little bit easier because the formula is right there? Okay, now I did not press the pi button. So take 2 times 12 times 6. That's where I got 144. So I kept it in terms of pi. Okay, give me a thumbs up or down. All right. Okay, so then the last thing for us to look at is, what would a combination figure be? And I might have to click through. I had some more examples that we're going to skip at the moment. Okay, here's a combination shape. It's I just need to pick a way for us to go through. So I'm just picking the one that seemed to make sense as we were discussing. Okay, so let's do lateral area of this rectangular prism. It'd be nice if it were a cube, but it's not. So let me try and point some things. This one, we want the lateral area. How do we do lateral area of the prism? Perimeter times height. So what's its perimeter? 4 plus 2 plus 4 plus 2? 12. And what's its height? 3. So 36 for the lateral area. Okay, and then we wanted the bottom base. All right, we want the bottom base. So that would be 4 times 2 or 8 for that one. I'm gonna list over here. I need to add these things together in the end. Okay, now what did we want from the triangle part? Okay, you want the 2 triangles? Should we do that? Okay, the triangle is 1/2, what's its base and its height? Height 3. Base is 4, so 1/2 of 4 times 3, half of 12 is 6. We have another triangle back here, don't we? So we want 2 of those. So we want a 6 and another 6 for the 2 triangles, or 12. Okay, what do I still need? I think I need these 2 rectangles, right? Now on my model, they're the same, but they're really not up here. Okay, this rectangle is what by what?
3 by 2.
3 by 2. Yep, the 2 is that width. Okay, so this one is 3 by 2, which is another 6. And how about, let me do a different color, this rectangle?
4 by 2.
Not 4. What's this length?
5.
Not 25.
Or forgot to square root.
Okay, he's doing Pythagorean theorem, I
5.
think. Recognize the Pythagorean triple,
3,
3,
4,
4, 5. So this is 5 by 3, or excuse me, by 2. 5 by 2, 10. I think I just need to add everything up now. Nothing to subtract because I never added in something I didn't want. What's it add up to be? Did you do yours, Riley?
672.
Okay, I think it was 72, last period anyway, square centimeters.
Yep,
Okay, now honestly, this is the hardest thing to think through in this chapter, okay? The surface area when you have 2 things combined.